Okay, in this video, we're going to talk about functions, but mostly about function notation. All right, so what function notation tells us? First off, the letter here, f of x, is kind of gives us a name to the function. So maybe you have a function called g of x, h of x. Really, it can be any letter. We tend to avoid letters like I of x because that's, the I is the imaginary or the complex number. Or maybe we would avoid like x of x or y of x because those are kind of confusing. But in general, it doesn't have to be. It can just be any letter you want. We usually start with f. And then if we need more, we just go down the alphabet, G, H, but it could be any letter. So f is the name of the function. What is inside the parentheses here is the input of the function. So that tells you what to plug in. And then on this outside, it tells you what operations are going to happen so you can get an output. So you can think of it like a machine. Hopefully you've seen a function this way many, many times, where you input a number, any number that's in the domain. So every once in a while, there'll be a number that you can't input because your answer won't be defined. So it wouldn't be in the domain. However, here we can input anything we want. And then we do the function. F is what gets done to the value. So say I plug in the number 7 into this function f. So that means where I see a 7, so f of 7, means 7 is what got plugged in. And then what I do is whatever it says to do to x. So I take 7 and square it, and I get 49. The benefit of this notation is that when you just write it out, f of 7 equals 49, you're making it clear what you plugged in was 7 and what you got out was 49. And I forgot to write that there. In general, what's nice about functions, what we can say is we're really more often concerned with the y value because that's the value of the function. That's actually what's given. That's the dependent variable. Usually the x, since x is the independent variable, it just kind of tells us where or when it happened. So we could say here that the value of the function is, let's say the function f, is 49 when x is 7. So again, the 7 just kind of tells us where it happened, but the value of 49 is kind of what we talk about as the value of the function, and that's why it's kind of over here all by itself. 7 just says I plugged 7 into the function named f. Sometimes, so let's talk a little bit more about an argument. So what you could do is you could change what you're going to plug into the function. So instead of plugging in x, I could say plug in the value of x minus 3. So that would mean instead of doing x squared, I would plug in x minus 3 squared. In this case, x minus 3 is the argument of the function. It's what you are doing to the, it's what you're plugging in. So again, if you had a function machine here, and you're going to do the function f, now what you're plugging in is not x. What you're plugging in is x minus 3. So if x were to be 7, you actually wouldn't plug 7 into the function f. You would plug 4 into the function f and get out 16. So you can change the argument of a function, which means you change the input of the function. Now, often what we will actually see is it just written as its own function. So the function g of x is written as x minus 3 squared. In this case, we're still in the quadratic family of functions. And in the quadratic family of functions, as you can see, the x minus 3 is the thing that's being squared. So the x minus 3 is still the thing that gets plugged into the quadratic. So in that case, x minus 3 is still the argument. And you still want to think about it as the minus 3 is having an effect on the input of the function and not the output of the function.